Okay, this is the reflow oven. I just turned it on. On the side here, I just put myself some instructions to remind myself what to do. The first thing to do is turn the power on, check the fan's running. That's the PC fan down here. That keeps the electronics cool. Switch the element on. This switch connects the elements into the circuit. I've put that to isolate it so that when I'm calibrating and doing other bits and pieces, I can actually turn the heating off. Turn the heating on. The next job is to press V for 2 seconds. That's this one here. Press that for 2 seconds. It will say run. Then shut the door. That buzzing noise you can hear is the solenoid that's holding the door shut. Now the solenoid is actually connected to an output on the programmer, which is the low temperature alarm. And the idea of that is by setting one parameter, which is the low temperature threshold, I can change the temperature at which the door opens. That means I can switch very quickly between lead-free and leaded solder profiles. It's going to heat up now. It started to heat up. You can see the top number here is the temperature it's at, 51 degrees, 52. This is the demand temperature down here, which is gradually increasing. It's going to be a long video, this one. So I've actually got a pyrometer connected here. It's just showing the temperature inside the electronics compartment. 19 degrees, nice and cool. Some people I see have built them with the electronics in a separate box, but I think it's a bit neater to keep it all together for the sake of that little fan. Inside you can see the elements are on, but they're not glowing. They're pretty much black heat elements. With them on a while, they do get a very dull red, but not like some of the halogen ovens you see that are giving out loads and loads of infrared. The fan inside, I'm not sure you can see it. No, you can't see it from this because of the reflections. You can just vaguely see there. The fan sucks air in the middle and blows it out at the top and bottom, but quite gently. I've tried it in there with some quite small surface mount components, and it doesn't blow them off the board. It's like watching paint dry, isn't it? But the whole reason for building this oven is I wanted a convection reflow oven because I didn't want... I've seen other people have made ovens using halogen type elements, lots of infrared, and I've read quite a few comments that say that the black coloured semiconductors heat up much quicker than their pins do, and there have been problems with them overheating in the past. You can see the temperature is quite along on its profile now. It's up to 178 degrees. You'll notice it's lagging quite a bit behind the demand temperature here. That's because the last part of the profile, I've set a very high final temperature to make sure the element comes on all the time. That red light's on when the element's on. And the reason for that is to get the very fastest possible temperature gradient for the last part of the profile. The temperature control is done by the low alarm. You'll see when it gets to the right temperature, which is I think 236, in this case 237, the door will open, and that will be the end of the profile. Right, it's actually set a little bit higher. That opened at 242, and then open the door fully, it will cool down. Inside you can see the, although there's a green wire in there and a green wire, they're not the same wire. That green wire there, you can see, is the internal thermocouple wire that goes to the programmer. So the temperature of the electronics only got up to 24. It's cooling down quite rapidly now. So that's it. That is my convection reflow oven. A little bit of fine tuning to do with setting the maximum temperatures, a little bit of cleaning up and perhaps a few labels to put on the front, but that's about it. Thanks for watching.